Hello, my name is Noah Lee, and this is my submission for CSC313 Graphics and Visual Computing Assignment 1 of a Spinning Donut. In this case, you can see on the screen, this ended up being my submission. It doesn't look much. I just kind of turned it into a sphere. The way I did this is by modifying our R1 and R2 values. In particular, I changed R2 to be 0, which effectively removes the hole that would be in the center of the donut. It just becomes this fairly bland sphere that occasionally twitches and jiggles a little bit as R1 and R2 are modified by the cosine of theta and the sine of theta. There is an occasional little twitch of the graphics. I'll go ahead and stop the program for now, just so I can show off the code a bit easier. I'll briefly go ahead and discuss what some of these values describe. The integer for width and height, in this case, is the number of pixels, or the number of characters, I should say, that are allowed to be used in the terminal output for the image itself. A and B here are used to track two of the axes of rotation. In this case, they actually specifically track the X and Z axes. K1 and K2 determine the scale of the donut itself, with R1 and R2 defining the inner and outer radius of what was the donut. And in my case, since I removed R2, it became a solid sphere, with the theta and phi spacing determining the resolution of the image itself. We use a character array of a couple of different characters to determine a scale of brightness that can be used. I additionally added this line here, the println for a couple of empty spaces. And this is purely to make padding of the image a little bit nicer and to make there be more space between individual images. Z and B here store some of the data that is determined by the animation. On the first frame of every loop, we clear the entire buffer to prepare for writing new data. After this, we go ahead and write data to our loops. We do a bunch of math on all of our integers, determine some values on the circle by performing operations on the trigonometric values that we derived just previously. In particular, we modify B and Z for each quote-unquote pixel, B determining the brightness of each pixel, with Z determining the depth of each pixel, or the closeness to the camera. And in this case, pixel, of course, only refers to the character at the given position on the screen. In this case, we actually use parametric coordinates to determine the different points of the shape. After performing operations on Z and X, we then print the values that are in B, which are again the values that were determined previously to show the brightness of each point on the shape. Then lastly, we modify A and B to change the rotation of the object. And that will conclude my description of Project 1. Thank you very much. Bye.